Hi everyone, this is Sarthak Bharadwaj. Today we are going to talk about some of the most overused words in AI right now. Agent harness, loop engineering, context engineering. And instead of just defining them, we are going to build the whole thing around them in just 5 files. So let's start with the obvious one, the obvious question. If I'll ask you what an AI agent is, or let's suppose if you'll ask 10 people what an AI agent is, you'll get 10 different made up answers. So let me just give you the simple one and most definite one. The AI agent is nothing but the model plus harness. Model, we can consider any particular like LLM, VLM, or from any modality. So think of this whole diagram as we were talking about the whole AI ecosystem. The model is the engine, and the harness is the rest of the car. Take the engine out, put it on the floor, turn it on. It will roar, but it goes absolutely nowhere. Okay, so this is the last time I'm using the car example. From here on, we are doing the real things. So the actual definition of harness is the runtime environment that turns a model output into real actions. And once you see it that way, a lot of things make sense. So look at the companies here. I'll just zoom it in a bit. Yeah. So look at the companies here: OpenAI, Anthropic, Gemini, Kimi, Mistral. So all of them ship models. None of them ships the environment around that. And if you look at these companies, Cloud Code, Open Code, Cursor, Antigravity, you can see most of the models that we use in the platform, like in Cursor or Open Code or Antigravity, they might not be the proprietary models to them, right? So Cursor serves all the models across, different companies, like, Anthropic models you can use on Cursor, your Kimi models you can use in Cursor. So that environment is their product. So what they build is the environment around these models, and that environment is their entire product. They are calling the same models. You can call yourself for the same price, but what you are paying for is everything that happens around the LLM call that you are making there. So let me tell you about the four parts inside the harness. So the first one is tools. So tools is basically a function that you expose to the model. So the model returns a structure request saying it wants to call that function. Your code execute it and then hand back the results. Let's suppose you can make any calls like read file, write file, or in sort of the MCP sort of concept. You make the custom tools. Like if your software has some functionality, you convert the functionality into some tools. You make some tools that will handle those sort of functionalities and let AI use the tools to do certain things. The second thing is pretty explanatory. This is the memory. The memory is a state that outlives the process. It remembers everything around, like what is happening in the process. The third is the context. The context is the tokens that the model receives from one single call. It's bounded, it's limited, as you have heard that every model has some certain context window. So that's why something has to decide what goes in and what gets left out. So this is why context is important. The fourth one, and this is also one of the most important ones. These are checks. So checks are the verifications that are done by your code, not by the models, basically. This is a deterministic pass or fail that decides whether the loop keeps running or not. So those four things, that's a harness, and that's how we build a harness. And now we're going to build each of these ones, and we'll see through examples like how important is to build the harness. Okay, so now let's dive deep into the code itself and understand and visualize how the harness is actually affecting our whole AI code lifecycle. So before we say anything, we need something for the agent to actually do. So let me show the bug itself. Yeah. So this is the apply discount simple function. It takes the price and a percentage, and we have two tests here to break it. The first one is a 120% discount on a $100 item. It will return minus 20. So the shop can't charge you negative money. It should bottom to zero eventually. The second one is the minus 20%. It actually raises the price to 120, and a discount that costs you more isn't possible. So now here's a part I want you to pay attention to. Look at the doc string. It only mentioned the first rule, never go below zero. The second rule exists only in the tests. So the gap is completely deliberate here because the model is going to read the doc string, write the obvious fix here, and we are expecting it to still fail the test before we add the catch there. Okay, so uh, let's run it. Yeah, so you can see there are two failed tests here, which are obviously the 120 and minus 20 ones. And the argument of this whole video is right there on the board. The model was not the problem, right? So let's start with nothing. The first case of ours, so we are using OpenRouter for routing different models, and we are using the uh, Anthropic Sonnet 5.0 as the default model to do that. So you can see the task here. So task is the test and the demo slash testcard.py is failing. Fix the bug in demo slash card.py. So let me quickly run this one. Sorry. So I ran this now. Yes. So you can see we got the output like I'll help fix the bugs, but I don't see the actual content of these all files. So now you can clearly see like it doesn't have any sort of these functionalities to check what is in the files, because this is a simple LLM call. That's not an agent. That's kind of a chat box that guessed everything around that. And this is the thing I really want you to take from step one, is that intelligence was never the bottleneck here. The excess was, right? So let's now give it the access. And step two, we have added the tools. So this is, if we'll open the tool definitions, we have added the list files here, read files here, and the write files here as the tools, right? So, and you can notice that we haven't added any tool name as the run test tool, right? It's completely on purpose because the model gets to change the code. It does not get to decide whether the change works or not. So for this step, we are letting the model to just use the tools and play around with that, try to fix that. But we haven't added any sort of tool that is checking on top of that. Yeah, so now I think let me quickly run it here. But before that, I think I just want to tell that this is the part people massively overcomplicate. The model doesn't run your code. It cannot run your code, basically. It just emits a little JSON blob that says kind of, I would like to call read file with the path. So your function does the reading. Your function decides whether that's even allowed. This is the same concept we do in the MCP also. So let's go for these to execute this one. 02 tools.py. Right. Now this is pretty interesting. So you can see when we ran this the output is like, it read the file, got it by, now it's reading, but yeah, you can see it read card.py, but then it stopped because one API call is just one turn, it spends that turn looking around. It never got to the fixing part. So tool without a loop is just a very expensive way to read the file. So let's also fix that with the third one we discussed, is the loop. So this is the loop. And also there's a very famous term these days, is called loop engineering. So in loop engineering, it's like call the model, did it ask for tools, run them, append the results back into the message. If it doesn't work, call it again. Didn't ask for tools, then it done, it breaks. So two ways out, and both of them matter. Number one, it stopped asking for the tools, then it's natural that the second thing to break from the loop is the max steps. That's the hard stop. And and that second step is not optional. Without it, a confused agent will run in a circle and burn through the credits when you are asleep. Every serious harness has that number in it. So now, quick story around that, because this is where it gets very interesting at scale. So I also, when I was in Camel AI, I contributed to one project called the OWL, which is called Optimized Workforce Learning. Is the exact loop engineering that we added that time. I think this time it might be having around 20K starts on that repo. So you have a planner agent distributed subtasks to specialized workers, and every worker's on its own loop with its own tool and its own stopping condition. So if you need to check out the example for the loop sort of thing, you can try OWL for sure, definitely. It also topped the open source GAIA leaderboard that time. So okay, so now we'll go for the third one with the loop itself. Let's see what it comes up with. So in the first step, it read the file. In second step, it write the file. Yeah, and now docstring check discounts over 100 makes the item free. You can see now in step 3, it verified and found the bug here. It computed, it fixed it for the first use case that we already mentioned there. It matched the case here. So let's again check for that. Right, you can see now the 3 tests has passed. One is still here, like which got failed. So you can see that the pattern around that. It matched the doc string. I told you earlier. Yeah, it matched the doc string and completely missed the rule that was never written down. And the loop believed it because the loop ends when the model stops asking for tools. So now we're gonna fix the real problem. So this functions runs fire test and return the exit code, 0 or 1. No model anywhere near it. And remember what I said in the step 2. The model has no run test tool. Only the harness can verify that. The model writes the code, the harness creates it. So now when the model says it's finished, we don't just accept it. We run the check ourselves. If it's green, we stop. If it's red, it's actually PyTest output goes straight back in the next message and the loop keeps running. So the model is no longer who decides when it's done. It's gonna be your code now. So this is the single highest leverage thing in the whole video. If you take one thing away, take that. So this is our checks. So let me clear this too. We're done it now. This pass, loop is green. Now it's genuinely green. If you test the pie test, you can see all of them got passed. So if I want to be fair to the model here, because at first an incomplete fix wasn't stupidity. The doc string only stated one rule and it did what a responsible engineer does on the first pass. Harness got that what a model exactly missed. That's the entire job of harness. So one more thing, while we are here, there are two kinds of checks, and people constantly mix them up. Did the right thing happen? Is the unit test 0 or 1? No model needed. The second is, was the answer any good? Is a judge score. So keep them in separate suits. Mixing those two is very common mistakes in this evals. You can check out some of my other videos too. So all right, now I'll come straight onto the payoffs that I promised you at the very beginning, that the moat is not the models, it's the harness. So on the environment variable, maybe if we can, choose some other models too and try out these similar use cases, the checks. Let's say I'll use the model as OpenAI GPT 5.5, and then I'll run this checks again. You can see the checks are passed here too. I'll reset and again choose any other model. Let's suppose I'll choose the Grok one. Wait a second, XAI. Here, let's take Grok 4.5. 4.5 here. And let's go for the checks. So it's reading the file. It checked the project for the test or the other clues around. It again, read the file, rereading Py to double check the implementation. So you can see the different lab, different architecture, different companies, completely different training, but the all of the models are functioning like that. You can see the checks are passed here also. So the model is a variable, right? The harness is the product. So when people spend 6 months arguing about which model is the best, this is the actual scope of what they are arguing about. So let's zoom out on what we just did. So step by step, we moved every single decision out of the model and into the harness. What it's actually allowed to touch, how it runs, when it finished, what it can see, and finally, which model which turned out to matter the least. It's what a harness is. It's not one component. It's every decision you took back. So if you want to try it around, repos in the description. These are 5 files. You can run them in order. And feel free to share your thoughts, what you think about the experiment. And if you like my content, feel free to subscribe it. And thanks, and see you in the next one.